This week is, I've conned Brian Cranky. He's a soil extension educator here on East Campus. I'm going to turn it over to Brian, and Brian is going to talk all about soil and fertility. Take it away, Brian.
Thanks, Terry. Hello, everybody. Thanks for allowing me to present to you today. I'm going to also talk about some physical properties, not a lot about biological properties. When we talk about soil in general, there's the three legs of the stool. There's the chemical, which is fertility. There's physical, which is the actual particles. And then there's that biological, like microorganisms. So I'm going to shy away from that last, and we're going to focus on the first two. I'm going to teach you some things that some are going to be intuitive, some you've never heard of, and some you're going to say, why do we need to know this? I think having a general appreciation for some of the things that go into what soil is and just how precious of resource it is that we have will go a long ways into convincing yourself that we want to take care of it no matter where that soil is. If it's in your turf, if it's in your garden, if it's in our cornfields. Terry mentioned I'm an soil extension educator. My background is really with nitrogen management in corn. So I come from a totally different perspective in terms of soil management. Large landscapes, really worried about soil erosion, being as precise as we can with our nutrient application, because our impact, just by the sheer scale, is huge. And so I take that approach and I bring it here to the garden. I love gardening as well. I have some raised beds at home. I think being a steward in the field, we still want to translate that and be a steward at home in our garden. So that's the kind of approach I'm taking tonight. So some things might seem a little peripheral to what we need to know, but I hope you gain an appreciation for soil. All right, so what you're looking at on your screen is an idealized soil profile, as if it could just be perfectly laid out, and you could take a backhoe and dig out and look at the trench and see these distinct layers. If you've ever dug a hole, which as kids we all, I think, dug around in the soil and played around in the soil, you started to see these horizons. But what are they? Well, at the very top, if you can, I think I'll use my mouse for now. Just if you need more, if you need to see me, or if you need to see me pointing something on the screen, make sure to holler, because this is not something I normally do, is communicate this way. So if I'm not pointing to something and I'm saying I am, just help me out and say, Brian, we don't know what you're looking at or what you're talking about. So just keep me on track that way. Anyway, back to the slide. So at the top here, if there is, like in forests, pine trees are a good example, deciduous forests like oak trees, there might be an O horizon, which is just an organic horizon, if you want to think about it that way. It's loose. You can easily kind of scrub it out of the way, and that's decaying biomass, leaves, bark, lots of stuff going on up there. But it's not soil. It's part of the profile, but it's not quite soil yet. It's really the next layer that's what we love. That's what we garden in. That's where our crops grow, and that's the A horizon. We refer to that as the topsoil. And that is really dark in nature, and it's dark because of the organic matter that's been turned in there. And as you go down the profile, we get this E horizon, and it's supposedly alluviation, which means kind of leaching out of different nutrients and organic matter. And so I'm already approaching this from the top down. But what's really unique about soil is that it's really being built from the bottom up just as much as it's being built from the top down. And that's, if you look at the C horizon down here, there's unweathered parent material just below that. And this could be bedrock, for example. But above that is the C horizon, which is parent material. Now, what is most of the parent material you would find in Nebraska soils? There's two main types. Parent material can be blown in, and for a lot of Nebraska, a lot of our parent material was actually blown in from other areas. So if you've heard of less, it's a type of silt, which is a size of soil particle. It was blown in here, and then it was deposited on the land that existed at the time. And then the other factors that form soil started taking place. But then towards the eastern part of the state, the most extreme part, there's actual glacial movement that eroded and left this till, and that's the parent material. So parent material is really just kind of, what is your soil starting from? If you looked at it, it would just look like an undifferentiated horizon, all the same. But so what happens and how we get these distinct layers that you see here is based on the 5 forming factors, which would be the parent material, which we already talked about, but then climate is a huge one. So if you think about the far west part of the state where it's more arid, you have more evaporation, evapotranspiration occurring out there if you have vegetation, and that drives typically a higher pH, and we can talk about why later when we get to pH. But there's a totally different environment that's interacting with that soil, and as a result, you get different soil. This is obvious as that. When you get further to the east, we get a lot more rainfall, especially the extreme southeast. That rainfall is bringing in, it's working on that soil, it's breaking it down into smaller and smaller parts, and as it gets smaller, some of it actually leaches through. Well, that's part of the reason you get this E horizon. But so this E horizon erodes through, and a lot of that starts to accumulate in what they call a B horizon. So you're weathering from the bottom up because you have that parent material, but you're also weathering from the top down. It's this unique multi-directional process, which a lot of people think, just don't realize that it's coming up from the bottom just as much as it's coming down from the top. I think that's pretty interesting about soil. So with climate, that's a huge effect. But there's also the aspects of what's living there. What animals are there? Earthworms, bigger mammals, all those things burrow in the soil and redistribute it. And the plants that are planted there change it over time. There's a reason why the Midwest is the breadbasket. And that's because we had long-term prairie, perennial grasses, capturing carbon and putting it in that soil. And that's part of the reason why we have such rich, dark organic matter soil for a large part of the state. Now the sandhills, they're a different story. That's a different type of parent material that was blown in. So those are fairly new soils. I'm not a geologist, I'm not a pedologist, but they would confirm that with me, that those are fairly new soils compared to the rest that are highly weathered from more ancient times. So that's one aspect. Topography is a huge one as well. So if you think about looking out at the landscape and you see that mountain and it goes into the valley, that's a perfect example of the drainage that occurs. Water's eroding on that surface. It's breaking down those particles. It's causing differences in the climate because of that topography. When it's extreme, like a mountain, for example, the radiation's different based on what direction it's facing the sun. So all these things are coming into play. And of course, number one, how much time has that soil been sitting there to develop? It takes hundreds of years to create what we would call 1 inch of topsoil. So we're not talking about our lifetime here. We're talking about being stewards for the next generation and the next generation and the next. It's so easy to lose. We can lose it in a second with an erosion event. We take it for granted often, but it takes hundreds of years to rebuild with that weathering process. Just think about that. If you go to a sandy beach, how long is that sand going to be there before it weathers into smaller particles and smaller particles? It takes hundreds of thousands of years for this to take place. So if you're interested in kind of getting more nitty-gritty with this, there's some links here. The really, really great resource is the Web Soil Survey, if you've never played around with that. It's an online tool that you can navigate to your area, your farm, your garden, and it will give you all sorts of information about the type of soil that was there. Now, I realize I come from the crop perspective. The soils more or less are there unless they've been leveled for irrigation, back when we did a lot more flood irrigation style. So a garden may be a lot different. You know, you add a lot of different things to a garden. You add a lot of compost. You might have raised beds. I get it. But you're still on the foundation below of typical soils for that area. And I think it begs us to look into that and say, what is the condition? What would it revert to, I guess, if I stopped managing my garden or doing things? This is a great resource that points that out. Loads of good information. So do that on your own time. It's a lot of fun to go through. Now, you mentioned earlier, Elizabeth, that you said clay, sand, and then I'll ignore the rock comment, which was those weren't types of parent material necessarily as much as they were types of soil particles, soil texture. They can contribute to parent material based on where they come from and how they get there, but really it's about the size of the soil particle. That's as simple as it is. So when somebody says, I have really clayey soil or I have really sandy soil, what they really mean by that is simply how many of each particle is there existing in that soil. It's as simple as that. If you start with rock, that rock breaks down into smaller pieces, and eventually those pieces become the size of the sand particle. And that sand particle weathers from the different forming factors that we talked about on the previous slide, and then it becomes silt. And on and on and on, and eventually it becomes clay, which are these really thin sheets. They're kind of these amorphous shaped sheets of soil. It's as weathered as it can get. It's the smallest particle. And so that's as simple as that. Do we have any questions about soil texture before I move on? Or soil particle size, I should say, not soil texture. All right. So soil particle size, sand, silt, clay, that's it. Those three things. You mix them together in different percents and you get your soil texture. That's as simple as it is. And so if you look at the textural classes of sandy through clay soil, let's get to the textural triangle actually. It will help understand that better.
Can you go back and tell York County what they missed for the two parent materials in Nebraska?
There could be, well, there's at least three, which I'm just highlighting them. A podologist would be a lot better to answer this, but we have windblown loess, which covers a large part of Nebraska, which is blown in from outside areas, deposited, and then started forming. We have windblown sand. We have the sand hills. And we've got glacial till, I think, east of Highway 81, which goes through York. We start to get forms, no, actually east of Seward, we start to get to glacial till as the parent material, the starting form of the soil. Thanks for the question. Okay, so textural classes. The reason I'm making such a big deal about textural classes, and the reason I'm going to make a big deal about a lot of things, is part of what I'm trying to do is enable you to have a conversation with somebody if you wanted to seek more information on your own or how to remediate a situation in your soil. When we're talking about fertility, we're going to talk about pH quite a bit. If you're going to lime your soil to raise your pH or lower your pH by applying sulfur, a lot of that really depends on your soil textural class. Soil texture also really dictates water interactions in your soil. And so I'm trying to give you a little bit of jargon to help with that communication process. So that's why I'm focusing so much time on that. Now, Terry, I think you were transferring rooms at the time, but I think we should do this ribbon method kind of when we hit the second lull. Now, I'll explain the jar test. So what you're going to do when you do it, you're going to take your soap and you're going to take your soil and you're going to add water in there and the soap, and you're just going to shake it up for about 3 minutes as vigorously as you can. And what that soap is doing is it's It's dispersing the soil particles so they can no longer aggregate, or what they say in soil chemistry, flocculate. And when they're dispersed like that, you set that jar down, and now the most dense particles start to settle first, followed by the next, and followed by the last. And so the sand settles in about a minute or less, probably 30 seconds or less. Most of you may not have a lot of sand in your soil, or at least in your garden. Maybe I shouldn't have been so confident in saying that. You can prove me wrong, but the silt takes about 2 hours. It starts to settle, and then clay can take days to really settle out. Mine took a week to settle out. But the whole point of this, before you add the water and shake it up, or actually you can do it after, is you measure, after it finally gets done settling, you measure the total distance. The total distance here. And then what distance that clay takes up, you measure that, you do the silt, and you do the sand. And this is a really rudimentary way to get what percent is sand, silt, and clay. And then when you get those numbers, you go to the handy dandy soil textural triangle, and you look at each side and you say, how much sand do I have? And you look for the percentage and say there was 10%, you start in there. Using our example though, I have it drawn out already. Say we had 50% sand, we draw that arrow up. Say we had 20% silt, we draw that arrow through. And then there has to be the balance in clay, which would be 30%. And where they meet on that triangle, this is a sandy clay loam which fits within these bolded borders. And so that's your soil texture. Okay, so if you're trying to change that or modify your soil, this gives you a way to know which direction you would want to modify it. And it would give you some other insight as to how your soil will behave or react to your management. A lot of books will reference your soil texture. That's a critical point to know.